In our paper, we present Microsoft Purview, a system for central governance of data. To motivate the paper, we've seen in recent years organizations having more and more complex data estates, where they have terabytes or more of data spread across varying different systems, such as Hadoop systems, databases, and Office documents. And today, governance of that data is generally fairly siloed, and it's hard to apply policies to cover all these data sources, leading to various piecemeal policies in the different engines. And this leads to a cumbersome, error-prone, and expensive data governance system. To solve this issue, we present Microsoft Purview, which is a unified central governance system providing a single central pane of glass to manage the data estate. Purview combines automatic data discovery, classification, and policy enforcement to help achieve this. The Purview service consists of three different parts. The data map or metadata catalog, which holds the data information from the data estate, then a system to store and manage the classification data of this catalog, and finally a policy system used to enforce access control over the classifications. The data governance system provided by Purview applies over both structured data inside of databases as well as document data such as Office 365 documents. Looking at the architecture, we have a chief data officer on the left interacting with the Purview UI, and in here they can create varying policies. These policies are saved to a backing policy store, which is then distributed to the various engines such as a SQL database, Azure Storage, or others via the Purview policy distribution service. Additionally, any classifications can be retrieved from the varying resources directly from the Purview catalog. Next, Nivedita will describe the way Purview policies are built as well as the workflows used in Purview.
Thanks, Nicholas. So we'll go over Purview policies, which are essentially a consistent and scalable way to govern the data estate. Policy author does not need to express policies in source-specific language and, for example, grant revoke for relational databases and access control lists for file storage systems. They are basically based on the role-based access control model. Next. So here is an example of how an access control policy would be authored. It's highly scalable, and for example, if it is authored at the resource group level, it would apply to all resources that come below it. So here we can see we have given allow read on data in a specific database to Principal Raghav. Next. Access control policies can be further fine-grained using attribute-based access control. Here what we are saying is we are extending RBAC and we are saying that at the column level, we can allow access to some users and not the other. For example, only full-time employees can be granted access to data that is classified as PII. And again, this is scalable. That is everything, all data that is PII can be restricted access. Next. So let's go over an example workflow of how this would work end-to-end. Let's say if an ABAC policy is authored in a unified portal that spans structured data as well as documents. Policy is applied as rights management service over documents and through access control mechanism over data engines. So as an example, we start with a Microsoft Excel document that is classified as confidential. User who has access opens it and loads data into a SQL database. Purview then reclassifies it after scan. Same policies that were applied to Excel in the form of RMS get applied to data in SQL in the form of ABAC policy, restricting columns classified as confidential. Further, next slide. When a business user creates report over data in SQL, SQL propagates labels applied to columns and they flow to Power BI. And finally, when the Power BI report is exported as Excel, the corresponding policy is applied as RMS. And here we see some UI screenshots. Here what we are doing is we are defining rules for labeling. We are saying a column that has social security numbers, for example, is a sensitive information type. Further down, we also define protection actions that where we say which user has access and who does not. So here we are saying anybody who's not an admin does not have access to the data. And on the next slide, we see that when Purview scans the data based on these rules, we see that this data in the table has some classification, some passport number, email that is classified with the appropriate classification and a sensitivity label. So as we can see in the next slide, this data gets stored in our SQL database's metadata. So as you can see, we have passport number, SSN that are labeled appropriately with an ID, as well as the classification or information type. Moving on to the next slide, we can actually show the use case where when we select from the table as a user who's not an admin, he cannot read the data because some of the columns there have been labeled as confidential. Whereas, as in the next slide, whereas if we selected some columns that are not labeled, then those would be accessible or readable by that user. Moving on to the next use case, which is extending this to Power BI. So we want to see the same behavior, that is when a user who's not an admin tries to create a report in Power BI, he's not able to select or create the report because those labels are restricted. Those columns are restricted with labels. And similarly, when he's trying to select data that is not labeled, he's able to create a report successfully. And we can also see, as in the next slide, that these labels get propagated nicely to the Power BI dashboard. As you can see, the same labels have been propagated down that were defined in Office 365 down to Power BI. Over to the next details, that is implementation, which will be done by Nitish.
Thank you, Nivedita. Let's dig into how this is implemented in SQL Server. The same principles will apply for any other RPE such as Cosmos or storage, but we'll focus on SQL Server in this paper, this slide. So first, from some definitions. What is a policy rule? Policy rule consists of a principle, resource, an action, and a decision. And policies, which are a set of policy rules, are provided to the PDP or the policy decision point, and are pre-processed and stored in memory as well as in the metadata. Now, what is the algorithm? There are essentially two ways to update the policies. One of them is full pulls, which essentially gets the whole set of policies and pulls it into the SQL Server. And there are delta pulls, which are only for policy updates. We obviously need to handle out of order notifications with version numbers and soft deletes with versioning, and the details of this are in the paper. So what happens when a permission check comes in? The permission check is basically the inputs are a principal who's a user, a resource that is specified through a path, and an action. Now, the permission check is that input is matched against all the policies which are already present in memory, and the matches are identified to make a decision or whether to revoke or grant or deny access. One thing to note is that the SQL permission checks coexist with Purview permission checks. And suppose you have a grant on either would grant access, but if you have a deny on either, you cannot access the policy, and denies obviously override the grants. So this works hand in hand both with the existing SQL permission system. So it's an It's an extension. Now we look into how this is integrated with SQL query processing and the security caches. This diagram basically gives an overview of the PDP and the execution engine. I'll go into the details. So queries are compiled and the execution plans are stored in plan cache before any permission checks. The permission checks are done before the query execution. And we have caching for permission checks for repeated queries. Now, PDP maintains a in-memory cache of the policies in addition to storing it with metadata. And the result of the calls to the PDP are aggregated with the local checks before populating with the security cache. This enables us to leverage the performance gains we have, performance gains which come with having the security cache. The cache evictions, obviously when you have a cache, you need to evict it when the policies get updated. So we have a timer task in the engine, which is obviously pulling the policies. And whenever those policies are updated, we have a coarse-grained policy that we will essentially repopulate the cache. Now we move on to the performance evaluation. The baseline would be the SQL without Purview, essentially the SQL with Purview enabled, and we'll compare it with SQL with Purview enabled for both cases when caching is enabled versus caching is disabled. We run a TPCC benchmark, and these are the results. We essentially see just a 2 to 5% overhead. This is mainly due to the caches. Without caches, we see a 31% overhead. Essentially, what happens is the Purview is not in the hot path of data access when caching is enabled, and which explains most of why the performance, we don't take any significant performance hit. The details are in the paper. I'll hand over to Nicholas to cover the future work.
All right, thanks. So future looking work for us. Right now, Purview only supports a fairly limited set of SQL permissions, which are generally designed for a couple of specific roles and scenarios in Purview, namely performance monitoring, security monitoring, and read access to the database. In the future, we want to expand these permissions to be more comprehensive to the full SQL permission model. Additionally, we'd like to support additional attributes such as time-based attributes or location-based attributes for the access control policies. And we also continuously want to expand to additional data engines outside of SQL and storage. Next, looking at the related work in the industry, there are several offerings which support central data catalogs such as like the Google Data Catalog, but Purview is fairly unique in that it combines this catalog with central policy management for access control as well. In the access control space, specifically around like role-based access control, there are some open source offerings such as Ranger and Open Policy Agent. And for the more industrial offerings, we see a lot of use cases be more around like coarse-grained policies, such as access to the entire database, whereas Purview can support finer-grained policies down to like the table level. And that concludes our paper in which we presented Microsoft Purview. Thank you.